Hello, everybody. Welcome to another edition of the MakeCode Arcade Advanced stream. I'm Richard, at Richard on the MakeCode Forum, and I think it's just me today. No one else showed up, so I assume it's just me today. But I actually cannot get to my messages right now to figure out if that's the case or not. But hopefully, if Joey or Thomas are going to show up, they'll just pop in here at some point. Anyway, sorry that we missed a few streams there. There was an event going on in Seattle called the Blockly Summit, and because we do a lot of blocks coding stuff, we were there. I was giving a talk with Joey, and we were doing a lot of hanging out with all the various people who make block-based editors for learning to code. And so, yep, we were a little busy with all of that, so we didn't have stream on Wednesday or Friday. But we should be back to our normal schedule now. Before we get started, I also want to briefly call out, I put it up on the forum now, there is a mini game jam going on right now. Our last mini game jam was construction themed, and this one is, of course, destruction themed. So if you want to make a mini game jam game, please go check out all the details on the forum. We're going to be playing all of them at the end of the month, just like we always do. But for today, we're just going to be working on the project that we were working on way back in the before times, before our absences, which is an extension for doing layers of tilemaps. All right, so layers of tilemaps. Why would we want to do that? Well, the idea is that right here in this project, we have three tilemaps. Okay, we have this one that's the brick wall. We have this purple platform right here, and then we have this pink thing down here. And the idea is that we want to be able to have different layers of tile maps with their own little XY offsets. So I don't know if you can really tell, but this pink tile map here is actually not aligned to the grid of this outer tile map. So by having tile maps that can have those offsets like this, the idea is that you could use this for implementing moving platforms and things by basically having a layer that you move around that acts as a platform for all of your sprites. So that's the idea. And so far, we have kind of implemented the basic API for this. It works a lot like the background scroll thing. We have blocks for setting each layer of the tile map and for setting the X and Y offset. And we have replaced our physics engine with one that is going to work for all of our tilemaps. So what our physics engine is doing basically. Oh, hopefully I'm back. Sorry about that. My internet's being weird today. So hopefully we don't get too many stutters like that. But so we have a physics engine that's running the same logic that we normally do for tile maps, but it's running it for each of the layers one at a time. And we've got that working. We've got all of our tile maps in here. What we don't have working is the collision resolution. So for our bottom tile map, it works just fine. But see, I'm going to hit this purple one right here. So this purple one is a wall. It should block me. But if I hit this, it's going to teleport the duck somewhere, right? I actually don't know where the duck currently is. Just kind of got obliterated. Let's try approach it from this side. There we go. Okay. So we hit it right here, and we got teleported over here. Okay. So what's happening there? Well, our physics engine has kind of like resolution behavior for all of these collisions, right? It's trying, it like knows that when I hit a tile map in this direction, I need to put this sprite somewhere, you know? And right now, it's assuming that all of these tile maps are anchored at 0, 0, which is how all of the old tile maps worked. So when I try to hit this from the right, it's like, okay, I need to block this sprite and nudge it out to the right here. And so I'm going to do that as if I was at 0, 0. So this is actually changing my X. And if you were to take this tile map and move it over here, you would see that it fits perfectly. And that's because we are basically fixing the collision of the sprite by nudging it over here to the right, and assuming that our X starts at 0. So that's obviously not right. We want our X to be based on where the actual X of the tile map is so that we nudge it to right here instead. By the way, that also explains what we're seeing here. So when I did this, now my sprite is up here above the screen, right? Because it's assuming that this Y is at 0, and so it's bumping our sprites up above the tile map, and now it's just kind of stuck out there. So anyway, fixing this should fix all of these kind of collision things. And let's go ahead and look through the code and see if we can figure it out. I did not do much preparation before stream today because I had a fun thing where I accidentally had to reboot the computer a few times, the stream computer. So I didn't do much prep, but we can figure it out, I think. All right. So let's look at where we actually do this collision stuff. So this is going to be inside of the move function, which is right here. So this move function in our physics engine is what is responsible for doing all of the movement of sprites, and that includes all of the collision resolution with the tile maps. So here we have our sprite moving. Our sprite moves by a certain amount of X and Y for each check that we do. Each step we kind of break into smaller chunks, and we do that so that we make sure that we never like skip over a tile. We never want to have a tile on our tile map that like we don't file overlap events for, or like a wall that you don't collide with. So by breaking it into smaller steps, we can make sure that we're always checking steps that are smaller than one tile width so that we never just skip entirely over a tile. Okay, so we're running all of these steps. We're changing our X and Y right here. We are doing this tilemap collisions to function. This is what's actually doing our tilemap collisions, and this is also what is doing our like bumping out. So because we're not moving by 1 pixel at a time, when our duck actually moves down, chances are that while it's moving, it's going to briefly overlap with this tile map, right? We're going to move it down however many pixels. It's going to be overlapping with this tile map, and then our logic is going to be like, oh, hey, it wasn't overlapping before, but now it is. So let's just bump you back up a pixel. And that's what the behavior is seeing here. Normally, that would just bump you up to, you know, like right here. But because we have this bug, it's going to bump me up to above the screen because, you know, it thinks we're at 0. So we're going to go to our tilemap collisions to function, and we're going to look for where that bumping happens. Now, this is a really big function. So you can see it's 257 lines of code. And in here, we have all of our various movement cases. So our movement cases are either we are moving in the X direction to the left, we're moving in the X direction to the right, up, down, diagonals, all of those things. It's going to be one of these. And we have a bunch of if statements to kind of try and figure out what the right one is. So here we are actually moving. So we take our Y, we are adding in whatever the step is, and then we are checking if there is an obstacle. If there is, then we put our collided tiles, we like mark this tile as something that we hit. And then down here, this is where we're doing our bump. All right. So we are taking our X and we are adjusting it so that it is at the X and or it's aligned with the X axis of whatever tile we hit. And right now, this is indeed not taking into account the X of our tile map layer. So all we should have to do to fix this is, let's actually go ahead and put this in parentheses. And we're going to go ahead and do, let's see, what was this? Oh, TM. TM.x plus that. That should be it. And then we're going to do the same thing for this case. So this one is if we're moving in the right direction, which means we want to go to the left of the tile. This one's if we're moving in the left direction, which means we want to be aligned with the right of the tile. That's why you see this x0 plus 1 right there. Okay. So this, I think, should fix our case right here. And there you go. So we just fixed that one. And let's see if we fixed it on the other side too. Yep. Okay. So we fixed the case for when we are just moving in the X direction, which is great. But if I come down here from the Y, we're still going to teleport out of here. So let's go to the next place where we kind of do this. So here we go. If the Y diff does not equal 0, then we are doing our adding. We are grabbing our X. We're checking for the collision. And then right here is where we are doing our collision resolution. So just like before, we have this Y0 tile scale. This is going to be the top of our tile. And we want to go ahead and just add our Y to this. So go ahead and add that. And then same thing right here. So this is going to be the bottom of our tile. And this is going to be tm.y plus, there we go. And let's see, are there any other places we have to do this? Let's see, okay, and this is where we do our overlaps. So that's no, we don't need to worry about that. Okay, I think that should do it. So let's go ahead now and see. There we go. All right. So we're properly doing the collisions for all of our tile maps here. So you can see that it's working for this one, it's working for this one, and it's working for this one. So cool. All right. Okay. Cool. Okay, so we have the basic physics stuff done. I think that is the hard part of this extension. So let's talk about how we want to do the actual moving platform stuff. So we're going to go over to, is it main.ts? Yeah. So in main.ts, I have listed all of the things that we want to be in this extension. So I'm just going to go ahead and mark these off. Here, let's actually put little check boxes next to them. Okay, wait. Get rid of all these extra lines. Go. We're going to go ahead and do a multi-line cursor. And there we go. We've got all of these checkboxes now, and I'm going to check these off by putting an X inside them. So set tile map layers. We got that. Did that. Looking good. All right. All tile maps get drawn in order. We obviously have that working because we have our tile maps, getting drawn. Each layer has an X and Y offset. We got that. Looks good. Is colliding with tile map? Don't have this yet. Is overlapping with tile map? Don't have this yet. Overlap and collision events fire for all tile maps. So I'm pretty sure this will work, but I'm not 100% sure that it's going to work exactly right. So we're going to do some testings for this. Oh, hey, Joey. Nice of you to join us, Joey.
Got distracted, didn't realize.
Yeah, no worries. Okay. So we are, where we are, Joey, is we resolved that bug we have last time. So now we have collisions working for all of our tile maps.
Yeah. Nice.
All right, you're echoing for me, Joey. Can you say something real quick?
Hello.
Yeah, you're echoing for me, but maybe that's just me. It's weird. I haven't really changed anything.
I think I see that going on my excuse me.
I mean, it's a pretty cool effect, to be honest. It's like a reverb more than an echo. All right. So this is okay. All right, we're gonna have to do some tests to make sure this is working right. Okay, allow out of bounds. We have this going. I'm not gonna explain what that is. Let's see. We have set visible layer, get X, get tile map. Okay. So the important thing that I think we're gonna need here is this is colliding with and is overlapping with. And we are going to need this because we need this to detect when we should move sprites with our platforms. So we're actually going to go into, now that we have this basic collision stuff working, we're actually going to go to our test code, actually, which is right here. And we're going to change this to be a platformer because that's kind of our end goal here, is to have a platformer where we have tile maps moving around. So I'm going to take this move sprite. I'm going to change the VX to 0. I'm going to change the VX should be 100. VY should be 0. We're going to do my sprite.ay equals 500. And then we're going to do controller.a.onEvent, controller button event dot pressed. Oops. Then we're going to do my sprite.vy equals -200. Okay, and you might be like, shouldn't you be checking if the sprite is on the ground or something? Yeah, no, I don't actually care about that. I want to have Kirby jumps so that I don't have to worry about like jump height and stuff. All right, we're going to make this -150. But now my duck can jump around, which is good. So we can use this as our testing. And our goal is to make this platform move left and right for now. All right. So let's write some code to do that real quick. We have our set layer offset right here. And this is our layer 1. Okay. So our tile map right here, this is the layer 1 tile map. The background is layer 0. This one's layer 1, and this one's layer 2. So we're going to make this layer 1 move left and right. So let's write some logic to do that. We're going to go ahead and do a game.onUpdate. We're going to go ahead and say, let's platform left equal, and we'll do this as 8. And then we're going to do platform left plus equals 2 if platform left is greater than screen.width minus, we want it, it's 3 tiles wide. So we're going to do platform left is greater than screen width minus 3 times 8 pixels per tile. So that's 24. Then we are going to set platform left equal to, oh, sorry. It needs to be, we have also 1 tile here. So we actually want this to be 32. So we're going to go ahead and align it like that. And let's go ahead and actually set our offset. So we're going to go ahead and grab this set layer offset. And we're going to make this be platform left. And we should now have a thing. Yeah. So it now moves from left to right. Let's make it bounce. So we're going to go ahead and say, let moving right equal true. And then here we're going to say, if moving right, then we're going to do all this stuff. And in here, this is when we hit the wall. So we're going to go ahead and set moving right equals false. And now inside of the else here, we're going to say platform left minus equals 2. And if platform left is less than 8, then we're going to say platform left equals 8 and moving right equals true. So this should make it bounce back and forth. So bounce, 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 bounce. Okay. So right now, if I overlap, you see that I do not move with the sprite. Also, it just moves through our sprite. If our sprite happens to be in the location where it overlaps. So we're going to have to deal with both of these. We'll figure that out in a second. But for now, the idea is that when we move our platform, we need to detect, is our sprite colliding with this platform or not? Okay? Because if it is, then we want to move our platform by this, sorry, we want to move our sprite by the same amount as we move our platform, because our sprite is riding it. And so to do that, we're going to have to create this is colliding with tilemap API. Okay. So let's get started with this. First off, we're going to make this slow down a little bit. So let's actually go ahead and say dx equals 1. And we'll make this be dx, make this be dx. And now it's going half the speed. Cool. All right. Okay. So let's do this as colliding with. I'm hoping this will be pretty easy. So let's go back to our physics engine. In our physics, oh wait, no, wrong file, physics. So in here, when we collide with a sprite, we call this function, which is register obstacle right here. So this goes ahead and registers the obstacle, which is the tile we collided with. And this should run for every tile that we collide with. So we're going to go ahead and look at this code for this real quick, just to make sure that this is working like we think it is. We're going to go into game. We're going to go to sprite.ts right here. We're going to go ahead and Control F for register obstacle. There we go. And then we do this dot obstacles of direction equals other. Okay, so this is not what we want. So this is storing one tile in each direction, which is actually, that's not what we want, because it's possible for us to be overlapping more than one tile. So the idea here was I wanted to store all of the obstacles so that when I'm doing a check is colliding with, I can just check all the obstacles and check at the tile map that they like point to, you know? So we're going to have to make our own custom register obstacle that we can use to keep track of the tile maps that we're currently colliding with. So let's do that. We're going to head on over to, oh wait, by the way, where does this get cleared? So, okay, clear obstacles. So we need to see where this gets called. Clear obstacles right here. Okay, cool. All right, so we're going to go ahead and make our own function for register obstacle and clear obstacle. So let's go ahead and do that right down here. We're going to do function clear obstacles. This is going to take in a sprite, and we're just going to call sprite.clear obstacles for now. And then we're going to go into here and do function register obstacle. This is going to take in a sprite. This is going to take in a location. And this is going to take in a layer. Oh, wait, well, there we go. All right, so first off, we want everything to keep working as normal. So we're going to go ahead and we are going to call the normal one register obstacle. And we're going to go ahead. Oh, and this needs to take in a direction also. Okay. Register obstacle. Oh, this needs to take in an obstacle. Okay. Obstacle. Sprites dot obstacle. There we go. All right, so we're just going to go ahead and call register obstacle direction obstacle. There we go. All right, let's go ahead and call these two functions. So we're going to do a Control F for register obstacle. Now right here, we're going to go ahead and do register obstacle and do collision direction tile, like that. And we're also going to pass in S, and we're going to pass in our layer, like that. Go, clear that. I'm going to copy this because I'm guessing that I'm just going to be pasting this. Okay, next one right here, paste. All right, any more? Nope, that's it. Great. Hey, Joey, say something.
I don't think it fixed itself.
All right. I was hoping it would, but now you're still echoing for me. I guess I could unshare with sound and see if that fixes it. But I don't know why that suddenly broke today of all days, you know? Here we go. We're going to try that. All right. Try now, Joey.
Is it working now?
Yep. Okay. Well, we're going to have to figure out what that's about, but At least it's working now, kind of.
Mhm.
All right. So this is great. Let's head on back to what we were doing. So we were calling this register obstacle. That's all great. We need to store on our sprite that we are hitting this tile map in this direction. So we don't actually care about the location or anything like that. We just want to know, like, what tile map are we hitting in what direction, so that we can check, are we standing on top of this tile map or not. So we are going to store this as, let's see. I guess we can make a class for this. And in here, we are going to have an array of tile map layers, a double array. So we're going to go ahead and do collided with, and this is going to be a tile map layer double array. And then inside here, we're going to go ahead and do this dot collided with equals, or you know what, let's just do this inside of a clear function. So we're going to go ahead and make a clear function. And we're going to say this dot collided with equals that. And then we're going to do this dot collided with collision direction dot left equals empty array. And we're just going to do this for all 4 directions. I don't actually remember what these map to. I assume they're just 0, 1, 2, 3, but I'm too lazy to check. So
I think they are.
There we go. And then we're just going to call this dot clear in the constructor. Okay. So we're going to make a function right now, which is going to be called get collision data. And this is going to take in a sprite. It's going to return a tile map collision data. So sprites have a dot data property. And this is an object that you can just shove anything you want into. So we're going to make a key right now. This is going to be collision data key. And we're going to set this to TM layers collision data. This string doesn't actually matter, but you want to make sure that it's something that someone else isn't going to reasonably use. So, okay, we're going to say if sprite.data of collision data key, then return sprite.data of collision data key. Else new data equals new tile map collision data. Sprite.data of this equals new data. Return new data. There we go. So this will now get a tile map collision data off of a sprite. And if it does not exist, then it'll create a new one and put it on that sprite. All right, so down here, we're going to go ahead and say const collision data equals get collision data on sprite. And then we're going to do collision data dot here. Let's go ahead and make a function for this. We're going to do register, and this is going to take in a direction, which will be a collision direction, and a layer, which will be a tile map layer. And this is going to say if this dot collided with of direction dot index of layer equals -1, then this dot collided with of direction dot push layer. There we go. So now we can just do get collision data sprite dot register direction layer, like that. And right here, we're going to go ahead and do get collision data of sprite dot clear. Okay. And then finally, we're going to do is colliding with. This will take in a direction and a layer. And this is just going to say return this dot collided with of direction dot index of layer does not equal -1. Great, we did it. Okay. We're going to go ahead and export this function. All right. Okay. So with this, we're going to go ahead now and go over to our state function. Or, sorry, our state class, which is inside of custom.ts. So this is what stores all the state for our extension. And this is where we kind of implement all of the APIs that we surface to people. So we're going to go ahead and say is colliding with. And this is going to take in a sprite, a layer. This is going to be, a direction. Collision direction, and then a layer. And this is going to be an enum value. We have this layer enum value. And we're going to go ahead and, get the actual layer from our layers right here. So let's do actual layer equals this dot layers of layer. And we're going to say if not actual layers. So are we checking collisions against a layer that doesn't actually exist? We're just going to return false. Otherwise, we are going to return get collision data of sprite dot is colliding with direction actual layer. And that should do it. Okay, and now we need to go over to api.ts and to make the actual function for this. So export function is colliding with, and this is going to take in a sprite. It's going to take in a direction. And it's going to take in a layer. And we're going to go ahead and do just return state dot is colliding with sprite direction layer. All right. Okay. Cool. All right. So we have this is colliding with function now. Now we can head on over to our main.ts, and we're going to actually implement this movement stuff. So we want to nudge our sprite if we're on top of it. So in order to do this, we're going to go ahead and make a function down here. We're going to call this move platform. And this is going to take in a layer, which will be a tilemap layers.layer. And this is going to take in a dx and a dy. And then what we're going to do is we're going to loop over all of our sprites. Let's see, did I actually give it a sprite kind? I did. Sprite kind.player. If sprite, let's see, is tilemap layers.is colliding with, and then we want to check our sprite. We want to check down. And we want to check our layer. Then we're going to do sprite.left plus equals dx, sprite.right plus equals dy.
Right? Top?
Top. Thank you. And then down here at the bottom, we are going to set the actual thing. Okay, wait. We need a get. We don't have a get yet. Let's go over to our api.ts. There we go. And then we want to have the same thing for y. Great. And over to main. And we're going to do set layer offset, and this is going to be tilemap layers dot get layer x of layer. I'm sorry, that's y. We want it to be x plus dx y plus dy. Cool. Okay. Now let's change our logic up here. We're going to go ahead and change this to be, we're going to get rid of this set layer offset. And we're going to go ahead and do right here, move platform. And we're going to make this be our tilemap layers.layer.layer1. And we want our dx to be our dx, and we want our dy to be 0. All right. And then we're going to get rid of this platform left right here. And instead, we're going to go ahead and use our get x. So get x, and then don't bother with that. Just to make my life easier, we're going to go ahead and do this. It's annoying to use in text, but it'll be easier to use in blocks. Okay. Okay. All right, so good enough. We have it moving back and forth now. And now when we're on top of it, there we go. We're moving. Our little guy's grooving.
It's a little fun.
Okay. Well, we continue moving when we're in the air.
That's true because of what we how we have it written. When you're we're colliding with that to the left probably, and we're not moving to the left, so it's not clearing it.
Right. Did we forget we forgot to call our clear function inside of clear obstacles? Is that right?
Or is it still moving it now? Oh, well, we probably did forget to call that clear function entirely.
That must be what it is, right?
Yeah.
We're just never clearing it. Okay. Head on over to physics. And let's make sure we call our clear obstacles. Yep, right here. Okay, so we're just going to go ahead and do clear obstacles of S. There we go. So now I can ride this guy, and then when I get off, I'm no longer riding it. Great. All right, step 1. Okay, so we still have a bug here. And I'm not 100% sure how we're going to deal with it just yet, but the bug is that what if the sprite comes in from the side? Okay, so here I'm just going to try and, all right, let's see. There we go. Okay, so I don't know if you saw that, but the tilemap briefly moved into our sprite.
Mm-hmm.
All right. So we need some way to resolve when this happens. So let's talk about kind of what our ideal logic for this would be. So what I'm thinking is, this doesn't need to be completely foolproof. Okay, we're not going to handle the situation where you have one tile platforms that are moving really, really fast, so they could just move all the way through a sprite. Okay, if you want to handle that in your game, that's on you. I think what we're going to do instead is we're going to have an is overlapping with block, and when we do the is overlapping with, we can then determine if the sprite is overlapping with it after the move. We need to nudge it based on that. So we're going to do this in our game code. But first, we're going to need an is overlapping block or function. So let's go over here. We're going to go ahead and say export function is overlapping. It's going to take in a sprite, and it's going to take in a layer. And now we need to actually implement this. I think we're going to need like 2 versions of this. We need is overlapping, and we need is overlapping wall. Why is this set? Oh, we already have an is overlapping wall. Oh, okay, wait. Head over to physics.ts. Where is this function? Okay, right here. Okay, so we're going to rename this one. So let's go ahead and do rename symbol. We're going to call this underscore is overlapping wall. Oh, didn't like that. All right, let's just do a control F for this. Oh, it's only called right here, huh? So we're going to do underscore like that, underscore like that. Okay. All right, that fixes that. Okay. So let's start with is overlapping, because that's nice and easy. We're going to go to our state where we did our is colliding with function. And we're going to go ahead and do an is overlapping with also. So is overlapping with is just simply, we have 2 rectangles. Are they overlapping? Simple as that. So we're going to take in a sprite. We're going to take in a layer. We're going to go ahead and say, just like before, we're going to get our layer. So, oh, we already have a get layers thing, but whatever, it doesn't matter. So we're going to go ahead and do get our layer. If it's not defined, then we're going to return false. Otherwise, we're going to go ahead and figure out left equals layer dot x, top equals layer dot y, right equals layer dot x plus layer dot, wait. Oh, sorry, this should be actual layer. Actual layer dot map dot width shifted like this by the layer's scale. So actual layer dot map dot scale. There you go. And then we're going to do bottom equals, grab all this junk, make this y, make this height. All right. And then we can just do a normal overlaps check. So we're going to say if sprite dot, we're going to do like usual, we're going to figure out the inverse and we're going to knot it. So we're going to say if sprite dot left is greater than right, then we're definitely not overlapping. Or sprite dot right is less than left, then we're definitely not overlapping. Or sprite dot top is greater than bottom, or sprite dot bottom is less than top. So if any of these are true, then we're definitely not overlapping. So by ORing all of these together and just putting in a knot, then we have our is overlapping with check. Okay. Now let's do our is overlapping wall. This is slightly more complicated. So we're going to go ahead and do an is overlapping wall. It's going to take in a sprite. It's going to take in a layer. And it's going to start out the same. We're going to go ahead and grab this, stick that right there. And then we're going to go ahead and go to our physics, because I realize now that that function that we collided with is probably implementing exactly what we want, right?
Mm-hmm.
Okay. So this is overlapping wall right here. So this is just taking in a sprite. So this is going to take in the tilemap data, the offset x, the offset y, and allow out of bounds. Okay, great. Okay, so we're just going to go ahead and do return is overlapping wall is going to take in sprites, is going to take in layer.map. Oh, wait, actual layer.map. fx8 of actual layer.x. fx8 of actual layer.y. And then allow out of bounds. We're going to go ahead and set this to be true. We should actually make this not true for if this is the first tile map or not. So we're actually going to do that right now. We're going to say for const map of this dot layers if map and map equals actual layer, then let's see, we're going to do let is first map equal false. So if map and map equals actual layer, then we're going to say is first map equals true, break, else, break, and then we're just going to go ahead and put in here is first map. Great. Okay. Okay, now let's just go ahead and call this over in our API.ts. We're going to go ahead and do right here, return state.is overlapping, and we're going to pass in our sprite and layer like that. Oh wait, what did we call this? Is overlapping with. Okay. And then right here, we're going to say return state.is overlapping wall sprites layer. Great. Okay.
Oh, see a couple messages in chat. I shot a very interesting thing you guys made. Thank you for that. Hey, whoop whoop. Does the check input of the blit function just return true if there are any color zero spaces in the section being blit to? What function does that serve?
Okay, so this is not related to what we're currently doing, but the blit function, let's go ahead and look at that real quick.
Yeah.
We're going to head over to screen, which is right here. We're going to go to image.d.ts, and we're going to go ahead and look at the blit function. Wait, is that not in this file? Okay, so the image.ts. Blit. Okay. So blit has a lot of arguments. Let's go ahead and break them all down. So blit is for drawing a stretched or squashed image on top of another image. And so to do this, we take in the arguments a destination X and a destination Y. So this is just like when you call the normal draw image. This is the XY that you want it to be drawn at. Then we take in a width and height. So this is the how much we want it to be squished or squashed into this rectangle that we have at this location, right? So if I were to pass in the width and height of the image that we're passing in to draw, this would just draw the image normally. If I made the width bigger, then it would stretch it. If I made the width smaller, then it would squish it. You know, it's the idea. Then we have the image that we want to draw. We have the X, Y width and height of the rectangle that we want to draw. So you can also use blit to just draw partial images. You want to just draw a rectangle in the source image onto the destination, which I use it for that all the time, which is nice. Then we have transparent. If this is true, then we will not overwrite any transparent pixels in the source. If this is false, then we will overwrite them. So we'll write zeros to the destination image. And then check. And so check is a special parameter. If you pass true into here, then you'll notice actually that this returns a Boolean. Blit returns a Boolean. So if you set check and you say true, this will return true if there is any pixel in the destination that would be overwritten with a pixel in the source. Okay. So if there's a non-transparent pixel in the destination that would be overridden with a transparent pixel in the source, this will return true. All right. Now, what do you want that for? Well, this is what we use for doing overlap checks. So it turns out the code for drawing an image to another image and the code for checking if an image is overlapping with an image is exactly the same. So we made them one function. And so this check thing basically says, as soon as I hit a pixel that overlaps, stop, return true, which is what you want for doing the overlaps. So unless you are doing overlap checking, which I'm guessing you are not doing, just always pass false for check. The reason that we have it is because in our sprite scaling, we do want to check if our sprite is overlapping with the other sprite, right?
Yeah.
So that's where we use it.
And what I can figure out and what it's used for, sprite scaling is a good example. Like the 3D rendering type of things, it's another example that it's used for, right? To map from one place to another. Yeah. Those are the two that really come to mind, although it ends up being a lot of the time that you just use it.
That's true. I was assuming that you were familiar with the use case of Blit. So, but if you're not, like Joey said, it's mainly used for stretching and squishing sprites. So the sprite scale property. Okay. All right. So we now have our is overlapping with and our is overlapping wall. That's great. We're going to go ahead and use that to detect when we need to nudge our sprite. So we're going to go ahead and go down here. And after we do our move, we're going to loop over all of our sprites. Hopefully it says, yeah, I've used it. Yeah, I thought that was the case. And we're going to go ahead and say, is overlapping wall right here. And if it is, we're just going to do sprite.say squish. All right. Oh, whoops. Okay, so we start out overlapping, which is perhaps not the most useful thing here. Okay, I don't know why we... did that. Okay, we're going to change our sprite's location so that we don't have to deal with this. We're going to do sprite.bottom equals screen.height minus 10. All right, S. Sorry, not sprite, S. Could I run this project? Oh, my sprite. Okay, there we go. So we're going to go right here, and we're going to try to land on this platform. There we go. We do not have the squish text being displayed. If I hit this from the bottom, we also don't have squish being displayed. We're now going to do the bug case. So we want to have it come in from the side, and there we go. We got squish. So that is the accurate detection of what we're looking for. There you go, squish. All right. So that's all great. Let's actually do something about this. So if we are overlapping with wall, then we're going to say if dx does not equal 0, if dx is greater than 0, then that means we need to nudge the sprite to the right. So for now, let's just do sprite.left plus equals dx. Else, or you know what, we can just do this. This is going to be a little bit overly simplified, but we can just do our sprite.left plus equals dx, sprite.top plus equals dx. And this should actually, sorry, dy. And this should actually prevent our collision. It might be a little bit weird, but it should like make it so we get pushed out of the way. There we go. So now I'm getting nudged, right? Which is what we want. I think I'm going to turn off gravity for a second so we can really demonstrate this. All right, turn off gravity, turn on Y movement. All right. So now, there we go. I get pushed appropriately by this thing when I'm overlapping with it. And we also can get squished inside of it. So, okay, this is something that we have to deal with, right? So we can get pushed, but what happens when we get pushed into another tile map, right? Actually, I'm kind of surprised. Joey, I'm kind of surprised that we're not getting pushed into the wall.
I guess that one does it. I mean, it does push it back out every step of the way.
Yeah, I guess the
like the physics for step for the tile map is a lot more aggressive in the actual physics engine than this.
If we were to up the speed, then we would get hit into the wall, right? Like if I were to take this dx and change it to be 5.
Maybe. Oh, whoa.
Okay, well, or we'll just crash the game.
Maybe.
Okay, we'll have to figure that out. All right. Well, we're out of time for today, but we found a nice bug to work on Wednesday when we get back to this. So reminder, mini game jam's going on right now. Go ahead and check that out up on the forum, and we'll see you on Wednesday. I have been Richard on the MakeCode forum.
I'm Joey at J1 on the MakeCode forum.
And we'll see you later. Bye-bye.
Bye.